Hello, this is my answer to discussion number 4 regarding surface area. What we're trying to prove here is that we have this function of z that is a plane, let's say ax plus by plus c, projects onto an area, that the area of this, most of the area is k. We want to say if this plane, I'll read that equation, projects onto region D, and that's one plane with an area of this, is equal to equation of k equals square root of a squared plus b squared plus 1. So, well, here it is. Let me pull up the chair. There's Bob Ross style. So what we're going to do here is, first we're going to use our equation that we've from our surface area, and that's going to be a s equal to well, not that, it's going to be equal to the double integral of our region, or we'll say our region is D, and this to be the formula 1 plus the partial derivative of x squared plus, that's pretty not great, plus f added on to y squared d. It's not a good looking d. I'm very picky. D a. So with this in mind, I'm just looking at my I did it on paper. All right, that's right. So what we do here is we can actually start to find the surface area of this, and we can say that, okay, so we have a plane here, let's say z. Let's see, well, we can say that instead of making this equal to z, we'll say we get equal to f of x, y. So we have this equation. Now what we want to do is, for finding the partial derivatives, is we will use partial derivative of f with respect to x. We can see that when we do this, our variables, well, we can just say this goes away. With respect to x, we'll just take away the x, and we'll have our constant a left in the equation. And same story with y. Partial derivative of f with respect to y, we're going to get b. So then we can just plug this into our equation. A of s equals a double integral d square root of 1 plus a squared plus b squared dA. And now this works out real nicely, because if we look up here, this is, well, this, like, if you take away this and take away this, that's part of what we're trying to get to. So if we can say that a of s is going to be equal to our square root of 1 plus a squared plus b squared times the integral. We'll just say we could pull that out of the integral, because this is all constant, right? This will be our integral. Okay, it's a little bit long. Fix that. Okay, and worse. Integral with bounded on region D, dA. And we can just say, for people that like to put it there, I like to put 1 there, dA. So that means, looking at this, our region, has to be equal to the integral of dA, integral of 1 dA bounded on D. So we can say that a of s, we can say that k is equal to double integral d 1 dA or I guess another way you could write it, our function of A is bounded on, our region of A is going to be equal to, our function of A, that is going to equal this. So we can do this, and we'll just, using our little thing over here, we can say that 1 plus a squared plus b squared times k is equal to our surface area right here. And that, this form satisfies what we're trying to prove up here, that k times square root of square a times b squared plus 1 equals the surface area of this guy right here. And with that, that's the answer. There you go.